All right, folks, for the last few days, we have been working on solving absolute value equations and absolute value inequalities. We know that absolute value means distance from zero on a number line. And we have also seen that in every kind of absolute value problem that we solve, we have to solve them by creating two cases, a positive case and a negative case. Now, the last thing that we did last week is we were looking at solving absolute value inequalities that looked like this. So notice what this problem is saying. We are taking the absolute value of 2x plus 1. And what this problem tells us is that the absolute value of 2x plus 1 is greater than or equal to 9. So what that means is whatever this 2x plus 1 is, it is 9 or more spaces away from 0. So when it says that the absolute value of 2x plus 1 is greater than or equal to 9, that means that 2x plus 1 is 9 or more spaces away from 0. And so what we discovered is in this kind of problem, we were going to create two cases. Case 1 was the positive case, and case 2 was the negative case. Now what we discovered about that positive case is that to get it, we take this problem that we see as is. As is. The only thing that we do is we remove the absolute value bars. So instead of writing the absolute value of 2x plus 1 is greater than or equal to 9, we just write 2x plus 1 is greater than or equal to 9. So that first case is as is. Take the problem exactly as it is, but do remove those absolute value bars. Now in case 2, if you'll remember, there are two things that we have to change. So we take this case 1 that we've written down, and there are two things we have to change. We have to change the inequality sign, it flips, and we have to change this positive 9 to a negative 9. So case 2 is still going to start 2x plus 1, but instead of greater than or equal to 9, it's going to say less than or equal to a negative 9. So on case 2, you change those two things, the inequality sign and the number. Now, once we have written our two cases, then it's a matter of solving. So for 2x plus 1 greater than or equal to 9, we would first of all subtract 1 from both sides, which would give us 2x is greater than or equal to 8. And then we would divide both sides by 2 and get that x is greater than or equal to 4. On case 2, we're going to subtract 1 from both sides to get that 2x is less than or equal to a negative 10, and then divide both sides by 2 to get that x is less than or equal to a negative 5. Now, you will recall from what we talked about last week that that makes this a compound inequality. So this is going to end up either being a car bumper or airplane wings, an and or an or. So let's get this set up to graph. So 0 on there, and then I want 4, and then negative 5. So first I'm going to graph x is greater than or equal to 4. To graph x is greater than or equal to 4, I'm going to do that in blue. I'm going to put a filled-in circle on that 4, and then I am going to shade to the right, because I want x to be greater than 4. So there's what x greater than or equal to 4 looks like. For x less than or equal to a negative 5, I'm going to do that in red. That's going to require a filled-in circle on negative 5, and then I'm going to the left with that. So you'll notice this looks like airplane wings, which means that this is going to be an or. So the solution for the absolute value of 2x plus 1 is greater than or equal to 9 is x is greater than or equal to 4, or x is less than or equal to a negative 5. So that would be my solution. So two cases. The first one as is, that's the positive case. The second case, we changed two things. We flipped the inequality sign and we make the number a negative. Now, real quickly here, let me talk you through the interval notation on this, because I've noticed in the work that I've graded, some of you are having a little trouble with interval notation. When you're writing interval notation, you have to put brackets and or parentheses in your interval notation. It's not enough to just write the numbers. So you'll notice that in this particular graph, we've got this ray that's going to get one interval, and then this ray, which is going to get another. Now, this ray, if I look at this end, is negative infinity, and this end is at negative 5. So this part is going to be negative infinity to negative 5. Infinity always gets parentheses, because remember, x can't be equal to negative infinity because we don't know what that is. And then the negative 5 has a filled-in circle. Filled-in circles are brackets, so that would get a bracket. Now again, interval for this ray, we've got the number 4, and then out on this end, we've got positive infinity. So, whoops, don't want to do that. So on this interval, we're going to have 4, infinity. The 4 is going to get a bracket because he has a filled-in circle. So x can be equal to 4. And then your infinity is going to get parentheses. And then don't forget the or that we're using down here in our answer in interval notation is a u. So there would be the interval for that graph. So 2 cases, one positive, one negative. The positive case is as is. The negative case, we flip the inequality sign and make the number a negative. Now, today what we're going to do is the last thing that we need to do with these absolute value inequalities. And this is kind of going to follow the same pattern that we saw last week with absolute value equations. The first day with absolute value equations, we did really simple ones. And then the second day, we looked at equations where there was stuff outside of the absolute value bars. So if you noticed on Friday, we did kind of the same thing with our absolute value inequalities. We did really simple ones on Friday. And today we are going to look at problems that are more complicated. And they're more complicated because now there's going to be stuff outside of those absolute values. So the absolute value of 8x plus 10 plus 3 is less than 25. This is the problem we're going to look at right now. Now, what am I taking the absolute value of? Well, I'm taking the absolute value of 8x plus 10. So this is my distance. Absolute value is a distance. Now I want you to look at what this problem is saying. It's saying that if I take the distance from 0 to whatever 8x plus 10 is, and then I add 3 onto that distance, then that's less than 25. So this 25 is not my distance. It's whatever the distance plus 3 is. So you all will remember from our discussion of equations last week that your first step when there is stuff like this plus 3 outside of the absolute value is to isolate the absolute value. You need to get it by itself before you split the problem into the 2 cases. So isolate first, then do 2 cases. So I need to isolate the absolute value of 8x plus 10. To do that, I have to get rid of this plus 3. So to get rid of plus 3, I will do minus 3 on both sides. So that will give me the absolute value of 8x plus 10 is less than 22. So we are going to isolate absolute value first. All right, now that you have isolated your absolute value, now you can do your case 1 and your case 2. All right, case 1 is as is. So I'm going to take this problem and write it down as is. I'm going to write down 8x plus 10 is less than 22. Do remember to take the absolute value bars away. Case 2, I'm going to make 2 changes. I'm going to still start out with my 8x plus 10, but I'm going to flip the inequality sign and make it greater than, and make my 22 a negative 22. So there's my two cases. Now we solve. So over here, to get x by itself, we would first of all subtract 10. That gives us 8x is less than 12. Then we will divide each side by a positive 8, which will give us x is less than, let's see, that would be 3 over 2. So you could put 1.5 for that. So x has to be less than 1.5, or you can put the fraction 3/2. All right, let's solve case 2. To solve case 2, we would subtract 10, which gives us 8x is greater than a negative 32. And then we divide both sides by 8, which gives us x is greater than a negative 4. So x is less than 1.5. X is greater than negative 4. Now, I need to know if this ultimately is an and or an or. So let's set this up on a number line. 1.5 would be over here to the right of 0, and negative 4 would be to the left. Now, I'm graphing x is less than 1.5. So that would need an open circle, and then I would go to the left. For x is greater than negative 4, that would get an open circle on negative 4 with shading to the right. These are going to bump into each other. So this is a car bumper, so this should be an and. And I do want you to be sure that you determine whether it's an and or an or and put that in your solution. So when I look at your solution for this problem, I would expect to see x is less than 1.5 and x is less than a negative 4. Now, just a couple things here. You may remember that this one can be condensed because it is and. If I wanted to condense it, I would take the smaller of my two values, which is the negative 4, and flip this part over. So that would turn it into negative 4 is less than x. And then my x is sitting there waiting on me to say that x is less than 1.5. Now, don't attempt to do that with or statements. Don't attempt to do that with or statements, only with and, but we could condense this one. And while we're on the subject, let me talk to you about this interval. Your interval this time is this line segment. So the two numbers that you need to write the interval are already here. Negative 4 is at one end of the line segment, 1.5 is at the other. Now, can x be equal to negative 4? The answer is no, because that's an open circle. Open circles are equivalent to parentheses. Same thing for 1.5. X cannot be equal to 1.5, so that would also get parentheses. But only one interval required, because that graph is just that one line segment. So we're going to isolate the absolute value first, then split into the two cases like we always do, and solve. All right, next up, let's look at 9 times the absolute value of 3 minus x is greater than or equal to 72. Now, in this problem, I am taking the absolute value of 3 minus x, which means that this is my distance. Now this says that 9 times that distance is greater than or equal to 72. So I want you to notice this problem has stuff that is sitting outside of the absolute value. Something is happening to that absolute value. So I have to isolate it first. So how do I get rid of this 9? Well, since this is 9 times the absolute value, I would divide both sides by 9 to get rid of it. That would give me the absolute value of 3 minus x is greater than or equal to 8. And now that I have that absolute value isolated, now I can do my two cases. So always isolate first if you need to, and then do your two cases. So case 1, as is, 3 minus x greater than or equal to 8. Case 2, change two things. 3 minus x, instead of greater than or equal to, less than or equal to, instead of positive 8, negative 8. Flip the inequality sign, make the number a negative. And now we solve. So over here to solve for x, we would subtract 3 on both sides first. Notice that gives us negative 1x is greater than or equal to 5. Then I'm going to divide each side by a negative 1. Now you will remember that because we are solving inequalities and we're dividing by a negative number, we got to flip that sign. So this is going to be x is less than or equal to a negative 5. That rule about flipping the signs when you divide by a negative still applies here. To solve case 2, we would subtract 3. We get negative x is less than or equal to a negative 11. We'll divide each side by negative 1, which will make us flip the inequality sign. So x is greater than or equal to a positive 11. Now, I need to know if this is an and or an or. So I need 0. I need negative 5. I need positive 11. That looks like a negative. Let me erase that. All right. So for x less than or equal to a negative 5, filled in circle, and we go left. For x greater than or equal to 11, filled in circle, we go right. So this would be an or. So there's the solution I would expect to see from you on this problem. If I wanted to write my intervals, notice that your graph consists of 2 rays. Each ray is going to have its own interval. So this would be negative infinity for the arrow, and then negative 5. This would be positive 11 and positive infinity for the arrow. So I would go negative infinity, negative 5, and then 11, infinity. Don't forget I need brackets and parentheses to make this complete. An infinity is always parentheses. A closed circle is a bracket. Closed circle, parentheses, and then this would be a U. So that's what your interval notation would look like. Your first test is coming up on Friday, so that's something I want some of you to practice with just a bit this week. All right, so isolate, make 2 cases. That's how these all go, every absolute value problem. Isolate if necessary, make 2 cases. All right. Next up, 3 times the absolute value of 8x plus 5 minus 9 is greater than 24. We are taking the absolute value of 8x plus 5. So this is my distance right here. So I want you to notice there's stuff outside of that absolute value bar. There are things that are being done to it. It's being multiplied by 3, and 9 is being subtracted. So I'm going to have to cancel those things out. I'm going to have to isolate this absolute value right here before I can make my 2 cases. So when you're isolating, always take care of adding or subtracting first. So to get rid of minus 9, we're going to do plus 9. That gives us 3 times the absolute value of 8x plus 5 is greater than 33. Now take care of multiplying or dividing. So we divide both sides by 3, and we find out that the absolute value of 8x plus 5 is greater than 11. So now that I have my absolute value all alone, now I can make my 2 cases. Case 1, as is. 8x plus 5 greater than 11. Case 2, change 2 things. 8x plus 5 is now going to be less than a negative 11. Solve. Minus 5 minus 5. 8x is greater than 6. Divide by 8. Divide by 8. X is greater than 3/4, or if you want to go with 0.75, I'm okay with that. Subtract 5, subtract 5. 8x is less than negative 16. divide by 8, divide by 8, x is less than a negative 2. Zero, we need 0.75, we need negative 2. X is greater than 0.75 would be open and then right. Less than negative 2 would be open and left. I see airplane wings, so I know that or is the correct connecting word. So x is greater than 0.75 or x is less than a negative 2. If I were doing interval notation, 2 rays, each one gets its own interval. So for this ray, it's going to be negative infinity and negative 2. For this ray, it's going to be 0.75 and infinity. The infinities get parentheses. Negative 2 and 0.75 are both open, so they get parentheses. And then don't forget the U, which represents that word or. All right, we're going to do one last one. Negative 4 times the absolute value of x plus 9 minus 1 is greater than or equal to a negative 21. In this problem, I am taking the absolute value of x plus 9. So here is my absolute value. And I want you to notice that he is not alone. He is not isolated. So that is the first thing I'm going to do. He's being multiplied by negative 4 and having 1 subtracted. Take care of the adding or subtracting first. So you're going to do plus 1 plus 1. That gives you a negative 4 times the absolute value of x plus 9 is greater than or equal to a negative 20. And then we are going to divide each side by a negative 4. Now I want you to notice I'm dividing both sides by a negative. So even in this situation, that makes this inequality sign flip. So this is going to switch from greater than or equal to less than or equal to because of this dividing by negative 4. So I'm going to have now the absolute value of x plus 9 is less than or equal to 5. Now that my absolute value is isolated, now I go to my two cases. Case 1 as is, x plus 9 less than or equal to 5. Case 2, change two things. X plus 9 is greater than or equal to a negative 5. Solve. Minus 9 minus 9. X is less than or equal to negative 4. Minus 9 minus 9. X is greater than or equal to a negative 14. If I'm looking at a number line, 0, negative 4, negative 14. For x less than or equal to negative 4, that's going to require a closed circle, shading left. X greater than or equal to negative 14, closed circle, shading right. This is a car bumper, so this is an and. Which means I could condense if I want. Smaller value is negative 14, so I would flip this part. Negative 14 less than or equal to x. And then my x is waiting there for me to be able to say that he is also less than or equal to a negative 4. So this would also be acceptable as an answer. If I were writing the interval for this, notice it is one line segment. So I've got my two numbers, negative 14 and negative 4. They are both closed circles, so they would both be brackets. So the same thing holds true for these absolute value inequalities that held true for your absolute value equations. When there is stuff outside of those absolute value bars, isolate it first. Get rid of those things first, and then split it into your two cases. Case 1 is as is. Case 2, make the two changes. Any questions at all, please be sure and let me know. Try today's assignment. If things aren't going well, I want to hear from you. Y'all have a good day.